Okay, you're welcome to my channel. Now in this video, we're going to look at composition of functions, right? So written down here, so composite functions. So suppose f and g are functions of x, right? So we have two functions of x. The first one is called f, and then we call another one g. Then the composite function written as this, right? We just have a with this symbol O, which shows the composition of two functions. We'll see what it means real quick. It's defined as the same notation, right, to be f of g of x. Good. I know you're conversant with this notation from our study of functions, f of x, right, where we say x is an element of the domain of f, right, and then the corresponding result, which is y, is an element in the range. So looking at this notation, this right hand side here, you can observe that this g of x, right, that the g of x here is in the domain of f, right? And then the output here will be in the range of this composition of functions. Anyway, let me give you a little example so that we visualize this properly. So as an example, I'll give you a function. I'll say, okay, let f of x be given to be the square root of x, right? And then we give g of x to be, let's say 2x plus 1. Then you have to find the composition of these two functions, all right? So you have to find the composition of f with g of x. So f of g of x, all right? All right. Let's see how we are going to do it over here. So let me put down that notation again, f of g of x, right? Good. Now the first thing we're going to do is we're going to start with the inside function, all right? We have the inside function to be g of x, which has been given in the question to be 2x plus 1, all right? So what we'll do is in the inside function, I'm going to replace the g of x with 2x plus 1, all right? So that is just 2x plus 1. Good. Now we have f of 2x plus 1. Now, we want to figure out what this will be. Now look at the f function. F of x is the square root of x, right? So if you have the input to be x, this function will calculate the square root of that input. So what do we have here? Here we have 2x plus 1. So if we act on 2x plus 1, what it will do is that it will take the square root of 2x plus 1, because this is a function that takes the square root of any input, right? So here, this is going to give us f of that will just be square root of 2x plus 1. And this right here is what we call the composition of functions, right? So maybe I can put it down as f of g of x to be equal to the square root of 2x plus 1. So you start off with the inside function, and then when you're done with that, you now apply the outside function. So we started with the inside function, which was the g, by replacing it with its equivalent expression, and then we now apply the function f on that g, and the function f does what? Take the square root of any input, right? So it now take the square root of that input, and then that result we get is now the composition of those two functions, f and g. So that's how it is. Pretty simple, right? Good. Now I want you to notice something. When we're talking about function, I can show you as a mapping, right? So let's say this is a function g. This is let's start off with a domain of g. So considering f and g, all right? So let's start with the domain of g. G acts on element x. So let's say this is a set that contains some element called x. Good. So the function g now takes the output to what? To y. Just it takes elements in the domain to the range set. So maybe we can call the element in the y. And then what does the function f do? The function will now act on the output of this other function, right? So this takes this to that. Now f will now act on the output, which is this position, all right, and transform it to this place we call f of g of x. Good. So that is how the composition of function behave. The first function, the inside function, acts on the element in the domain and then produces the results in the range set. Now the range of the inside function now becomes the domain of the outside function, and it now produces a third result. So it's this third result that is called the composite function, all right, as we have it there. Okay, great. And now let's move over and solve a little bit complicated example still on this composite function. Just maybe we can apply this to more than two functions. It's not just two functions we can have three functions, the outside, the one at the middle, and then the one inside. Okay, great. All right, thanks for watching. Please subscribe to my channel.